So on the last lesson, we finished creating the external walls. So we already finished it on two parts of the buildings, and we started. So actually, we finished in the longitudinal direction to walls, and now we need to create the walls, external walls in the cross-sectional direction. So here is, as you see, I have already prepared the one wall with the opening inside it with the size 2 meter on the height 2.2 meter. So now I will select it and make the copy in all building, in all parts of the building. So I need to make 2, 4, 6, 7, 8 number of copies in y direction. So I will write 6 meter and 9. Okay. So first of all, I need to look at the material properties. Is it the wall number 2 or not? Because if the property is not okay, so it will be easier to select this wall if it will have the various properties from the other two walls. Maybe other, I mean just with the name of the wall. So wall 1 and wall 2. Because now I need to select all of them, and I just can press the button select model, and it will select only this part of the wall. So don't forget this opportunity to create some of walls. Wall 1, wall 2. Maybe you will not change the external uh, internal properties, but just will change the name of the walls. 2, 4, 6, 7 levels. So I will make the copy. So now I will check the height of my building. The height of my building is equal to 3.7 meters. Okay. I need to make copy on that direction. 3.7 meter 7 times. Now I will select all walls too. Maybe first I will unselect them, then I will select all them, and will copy it on the opposite part of my building. So I will check the length of the cross section. It's a 60 meter. So I will make copy on minus x minus 60 meter. Okay, that's all. So now we can say that our building is ready to add the load on them. So maybe I will press button save. Then I will make the pack of the model to see are there are all constructions with the properties or not. If there are not all constructions with material properties, they will color it red. And so the red colors will tell me about that there are no material properties on the constructions. So, okay. So I will open the table with the loads. Table with the loads. I had the last number 8. Last number 8. So Here I will also select this number and will accept this load. So here is a little mistake, 150. So own weight of construction. Okay, own weight of construction. Or dead weight. Mhm. Actually, let's create the load, dead weight, set as current one, go to the adding the dead weight. Here I will use only just the steel with the coefficient 1, 1.05. We will apply it. Then I will use all standard elements, plates, and the numerical elements with the coefficient 1.1 or load factor. Load factor. Okay, next load is the weight from the flooring. Weight from the flooring. From flooring. It will be live temporary or live load. The weight from the flooring is equal to 150 kilograms. So to add this load, first of all, I need to select my slabs because this load is added to the slabs, not on the foundation slab, but there are actual absence of foundation slab, but not on foundation slab and not on the top slab covering, not on the covering, only on the monolithic slab. So I select all of them. Then I use um, the option load on plates. I use direction Z and this uniformly distributed load. And here I will write 0.15 and press button. Then I will restore my model and I will use button unselect or press button and unselect my model. Next load. The own weight of covering constructions. So, okay, weight from the covering. Let's create this load. weight from cover instructions. It will be also live, temporary or live load. And it is equals 350 kilograms. In this case, I will select monolithic top slab, monolithic covering, will make fragmentation. I will select it again, apply the load on plates, 0.350 kilograms. Restore model, go next. The weight from the external walls. So this position is directly the weight of external walls, but we need to apply only the position of not the weight of external walls, but some additional elements of on external walls, like finishing title elements or maybe some isolation elements and so on. So here maybe I will use not in position in tons, but maybe in kilograms. And here I will write 140, 145, 115, 25, 160 kilograms. On 1 square meter. So here I need to write 1 square meter. 1 square meter. So as for me, it will be 120 kilograms per 1 square meter. Now I will select my external wall. Masonry wall 1 and the masonry wall 2. Fragmentation. Go to the load, add the load, and here I will write load from the load from isolation. Load from isolation. Okay. I will select all walls in one time. I will use loads on plates, the same direction Z, and here I will write the 120 kilograms. Okay, go next. The next load is the load from the internal walls or partitions, actually. Let's create this load. Load from partitions. partitions. I will apply it. We'll go to the table with loads, and we'll find that the load from the partitions is equal to 280 kilograms. Here is on 1 square meter. On 1 square meter. I will restore my model, and I need to select my slabs. I will not select the top slab covering because there are no partitions laying on it. So I need only select intermediate slabs. I will use load on plates to 180 kilograms per square meter. Restore model. The weight from the staircases. So actually there are no staircases in our building, and also there are no openings. So I think that in this case I will not delete the part of the walls, because in the previous video you can find the information about how you need to delete some parts of the slabs. That's why it's not so important now for us to delete some part of the walls and select and accept on the edge of the openings in the wall the load from the staircases. That's why, in my opinion, um, will not use this load in this case, and will not add it into the construction. Next load is payload. Payload is a load which are added on all slabs, but not on the covering, just on the slabs. Payload. Payload. Again, I will select the slab, all slabs, not the top slab, just other slabs. Select all of them. Uh, 195 kilogram. 195. Restore model. Snow load. 180 kilograms for 1 square meter. So now I will see. Is here some information about snow loads? No. So here we have no information about snow. Okay, so we'll just add this calculated load. So will consist like this is the calculated one, not the normative load, because In the previous videos, you can find information about how to find the total snow load. Most of all, according to the region of construction, we have in the normative documentation the normative loads. And then according to the slope of the roof, slope of the covering, um, also the safety coefficient, we can find the calculated load. So just I will accept like this is a calculated load, not normative load, but just a calculated load. And so I will not multiply it into the safety coefficient without it. Just will apply this number, 180 kilograms per 1 square meter. Go to edit the load cases. We'll create the snow. Snow load. This is a short-term load. I select the slab. I'm sorry, not slab, the top slab, monolithic top slab covering. Go to the load on plates, and so 180 kilograms. This next one. So here is information about wind region and the seismic load. In this case, so if I'm not mistaken, when we make the analysis of reinforcement concrete buildings, we applied the load, the seismic load. And so for this building, we will apply the wind load. So wind load is actually should be calculated by using the some formulas, additional formulas, and we have it here. So there are the normative load, which will accept according to the region, wind region. There are also coefficients which accept the change of the wind pressure according to the increasing height. And there are aerodynamic coefficient which will be applied by us like 1. So according to my task, the region of the wind is 1A. The type of the region is C. So here I will write this information. Not at all. So due to 5 meter it will be 0.4. So 10 meter also 0.4. To 20 meter 0.55. Let's check the total height of my building. So I will start checking it from not the basement level, because we decided that there will be one basement level, and we'll start just from the substructure, superstructure of the building. Sorry. So it's about 30 meters. 30 meters. So 20, and here I will write 30. 30 meters. So for 30 meters, I need to find the uh, this coefficient k. So it will be equal to, for 40, it will be, so I will use some paper, and I will find the number directly for the 30 meters height. So for the 20, it will be 0 0.55. For 40, it will be 0 0.8, and I need to find 30. So just not so difficult. 25, I will divide into 2, 12.5 plus 0 0.55. It will be 0 0.6675. Okay, so I will write here the number 0.675. Okay, so the normative pressure of the wind is equal to 70 kilograms. 70 kilograms, or 0.017 tons. I will delete the last line. The K coefficient K will be 1, aerodynamic coefficient also will be 1. So now you see that there are 2 points with 0.8 and the 0.6. So when the wall is meet directly with the wind, we'll apply that load with the coefficient 0.8, and the opposite wall, for that part of the wall, will apply coefficient 0.6. So now we need to find the total load for the walls. How we can do it? We need to multiply all these positions for each other, between each other actually. I can use my telephone, and it will help me to multiply all that elements. So my loads actually will be not so huge, because the region is 1.1A with only 70 kilograms on screen. It's not. It's one of most weak wind loads that I can apply for my calculation. So it will be the second position will be the same. 0.55 multiplied to 0.017, 1.4. it will be maybe easier to okay, maybe I will open the Excel. Okay, right, because I spent so many time, it will be easier to use the Excel program. Put it here. I will create the special formula. And it will be easier. So I advise you also to put this table into the program, and it will help you to easily calculate the load. Now I need to multiply this number to 0.8. And multiply the total load 0.6. Okay, that's all. So now I will use this to um, positions for loading my wall on the height 5 meter, from 5 to 10, from 10 to 20, and from 20 to 30 meters. Let's create the load, wind load. Wind load on X direction. Masonry wall number 1. So according to X, let's see, is it X direction? So no, it will be Y direction. I need to select the wall 2. Okay, that's it. Now I need to select 5 meter height. It is 9 meter, 7.4, 6 meter, and this is 5 meter, 5.9. Okay, 5.9 will be enough for us. I use the gain load on plates, X direction. I will use non-uniformly distributed load. Make the copy of my load. The P1 will be 0, and the P2 will be. So now it is on the opposite direction, and I need to use it with a minus form. Or I need again to select it. Mhm. That's it. I will select this place, make the copy of for opposite part of the wall, the x direction along z axis,